Hey mathematicians, Happy New Year! Let's do your homework. Okay, so on the front we have the models, the pictures that I want you to write an equation and solve. So at the top we have x and we have 11. Since they're in the same rectangle, then they are going to be on the same side of your equal sign. And on the other side is going to be the other rectangle, which is 28. Now, our goal is to isolate to get x alone. So if this whole bit is x, we need to take off this 11, which we show by minus 11. That's a take off. But we can't just do that to this rectangle because then they're not the same size. We also need to take off 11 from our 28. So we're going to subtract 11 there. These two cancel each other out. That's the whole point. Isolate means get the letter, the variable, alone. X is now alone. We already have it right here. And 28 minus 11 is what your solution is going to be. X equals 17. So that's how you write it. This number 2 is just a little bit different. It's just showing you a balance instead of the two rectangles, but same idea. Balanced means they're equal, so write me an equation that says you've got 42 on one side. It equals x and also 29. I just drew it on the picture. You need to actually write it right here, and then you need to solve it. You can say here x plus a negative 7, or you can just write this as x and a negative 7. Don't just stop there because that's an expression, not an equation. You need to finish it. Number 4, different than what we've seen in class, but really same idea. X and also 19 are the same length. You can see it starts at the end and it ends at the end. Same length. They're equal to 32. There's your equation. You need to isolate x and solve to see what it is. One number plus 19 makes 32. On the back, we've got some review from Unit 6. Find the value, that means the answer, in standard form. Standard form is not the what is the problem. Like this shows a multiplication problem, which you need to write, but that's not, you don't stop there. That's not the answer. This is common mistake. 12 times 3? No, it is not. This is 12 to the power of 3. This is 12. 3 of them. That's 1, that's 2, that's 3, and they all get multiplied together. So find that answer and multiply it times 12 to get your final answer. I should have spaced this one out a little bit more. 4 times 4 times 4. Keep going, and then solve it. Prime factorization, that's when you are decomposing a number into its factors, just not one times something. 125, let's see, I can't cut it in half. Oh, it ends in a 5. I could divide it by 5. How many 5s go into 125? You could figure that one out. It's 25. And then you have two factors. I only circle them if they are prime numbers. The most common prime numbers that you'll see here, 2, 3, 5, 7, 11, 13. There are more, and maybe there are more in this answer, but those are the ones that mostly you see when you decompose your composite numbers. So this is a 5, we'd circle it, and we'd keep decomposing 25. Remember that you need to write your final answers in order of least to greatest bases, and if there are exponents that you could use, you need to use exponents. Simplify the following expression. Simplify means write it in an easier to understand way, which maybe is just a one number answer. To do this, we are following order of operations, GEMDAS. And you know I will be super picky about how much work you showed, so let's put it all on the page. Are there grouping symbols of any kind? Parentheses, brackets, braces, not commonly seen. Oh, that was not a pretty brace. Hold on. Not commonly seen in 6th grade, but absolute value symbols would also happen at this time. None of those are in number 1, so I'm going to move on. Are there any exponents, like a little power of 2? Not in this one. Are there multiplication and division symbols? Yes, there are both. This little arrow right here is to remind you that you are not going multiplying and then dividing, always, always. You just read the problem and do whichever symbol you see first. I happen to read 16 times. Oh, I read that symbol before I read this dividing symbol, so I'm going to do this one first. 16 times 15, woof, okay, I'm going to do that to the side. 16 times 15, 5 times 6 is 30, carry my 3, 5 times 1 is 5, plus 3 is 6, 7, 8. Placeholder 0, 1 times 6 is 6, 1 times 1 is 1, add that all up. 0, 6 plus 8 is 14, 240. Divided by 5, plus 12. I'm not ready to cross off this multiplying and dividing level because I still have a division problem. Since that's a higher order of importance than adding, I'm going to wait to do the plus 12 till I'm all done. 240 divided by 5. Ooh, again, these are not ones I'm doing in my head. I'm going to go off to the side and actually divide it. 5 goes into 2. Nope, 0 times. 5 goes into 24. 5, 10, 15, 20, 25, too big. 4 times. That gave me 20, so I have a remainder of 4. Bring down my 0. 5 goes into 48 times. And I have no more remainder, so I'm set. 48 plus 12. I'm done with my multiplying and my dividing level. I only have one thing left to do, so I'm going to do it. 48 plus 12, that'll give you your final answer. So you need to follow order of operations for each problem, and it might just be worth your time to write your checklist for each of them. I'll give you one more hint on this one. Since there's a plus and a minus in this parentheses, in this grouping symbol, which is where we start, we're going to follow our order of operations and say, oh, adding and subtracting are on the same level, so it's whichever one I see first. I happen to see this plus first, so I'm going to do 10 plus 43 is 53, minus 5, put the parentheses, write the divided. I know that you guys fight me on this, but you will not make a silly mistake if you rewrite the whole problem. Otherwise, if you do a little bit here, a little bit there, you're going to forget something. You're going to put it in the wrong order, and we don't want that for you. So keep going. That's your next step. After that, don't do the division. Exponents is the next level. And that's it. We're done with our homework.